Hi, I'm Ross Gardler. I work for the Azure Compute team. I do a lot of work around open source software. In particular, I'm working in the container services, so working with Docker and Apache Mesos and other microservices related technologies. So I'm going to be talking about that for the next 25 to 30 minutes. So let's get going quickly. So where do we fit in the bigger scheme of things for all of these things we're talking about at AzureCon? Well, we're right down here in the bottom left where it says virtual machines. You'll see a little box in there, containers. Most of what we're going to talk about today is in containers. But because we're talking about the infrastructure for running container applications, we will be talking a little bit about pretty much everything at that infrastructure level. But mostly we'll be focusing inside the virtual machine box, inside that little box named containers. So let's go straight into the agenda and then into a demo. So we're going to start off with an introduction to containers on Azure. Then we're going to look at the dev test workflow for container-based applications. Then configuration as code. So how do we manage this as code rather than as a set of scripts, etc. Then we're going to look at a problem that will emerge as we build out our application, and that's the single host problem. You need to be able to scale beyond a single host, so we're going to look at steps for enabling that. And we're going to start looking at the microservices on Azure, container-based microservices specifically on Azure using Docker and Apache Mesos, and the kinds of infrastructure that you can build to support your applications. And then finally, we're going to have a little glimpse at the future. And most importantly, at that point, I'm going to ask for feedback about that potential future. I'm going to skip over this slide quickly. It's lots of content in there. Download the slide deck, and you'll get lots of resources that refer to everything that I'm doing in this session. I will highlight the demo application link at the bottom there. All the demos that I'm doing here, you can download the source code for those and run those demos yourself. There's also extra documentation in there about how to run the demos, etc. So feel free to grab that code and play along. So I want to make sure that we're all on the same page to start with. So I want to do a very quick introduction to what containers are and how you would run them on Azure. So if you understand Docker already, then you'll probably understand everything I'm going to talk about here. It's a very high-level 101 introduction to containers that'll give everyone enough information to be able to understand the rest of the session. So let's switch over to my demo machine. This machine is a Linux machine. I happen to be a Linux guy, but everything I'm doing here could be run from a command prompt in Windows as well. So in the Linux machine, I have Docker running. So I can do Docker version, and we can see we've got the latest version of Docker 1.8.1. In the bottom half of the screen there, you can see that we're running every half a second, we're running a command called Docker PS. Now what Docker PS does is says what processes are running on this engine at this point in time. So you can see that there are no processes running at the moment. We're not running any containers on this machine at the moment. So let's run one. It's as simple as saying Docker run, and then the name of the container that you want to run. I'm going to hit return, and this is all going to happen very fast and scroll off the screen before you realized what happened. So it's now completed, and I'll scroll back and show you what happened. So there's the command I ran, Docker run hello world. And the engine has said, okay, I can't find an image called hello world, so I don't know what to run here. Let's have a look to see if we can find it in the Docker Hub. The Docker Hub's a public repository of containers that you can use to download and run certain applications. And the Hello World one is exactly that. It's a Hello World container that does something very simple. So it finds that in the Docker Hub and it pulls it. It brings the image down to this local machine. It verifies the image is the one it thought it was. And then finally, it runs it. And you get hello from Docker and a little bit more information about what is happening here. And that's it. That's what all that this particular container did. And you can see at the bottom, there's still no processes running. And that's because this container ran and then stopped very quickly. If I run the command again, exactly the same thing will happen, but this time it doesn't need to pull the image down because it's cached it locally. So it happens even faster. Now, what we did there was download a complete container with everything you need to run this simple application. But we didn't have a long-running process as a result. So let's run a long-running process. We need to run it in detached mode because I want to be able to come back to my command prompt here and run some more commands. We need to expose a port because this particular Hello World application is a web-based Hello World application. So I'm going to expose port 80 on this machine to port 80 on the container. And then I'm going to give it the name. Tutum is the publisher, and Hello World is the name of the application, the container that I want to run. So the same thing's going to happen here. It pulls down the image because it doesn't have it locally. It's a little bit of a larger image than last time because it needs more content. It's got a web server and things like that on it. And then it runs it as a process. And we see the ID of the process. And in the bottom part of the screen, you can see the process is actually running. So if we just switch out to a browser and we go to my machine, which is a machine in Azure, so it's in West US on Azure, and I hit return, we get the Hello World response from that particular machine. If I now stop that container, and the name I'm going to give it is the one that appears in the bottom there. It's a randomly assigned name from Docker. So I've now stopped that container, and I can refresh my browser, and of course, it's not there anymore. So that's enough to know that we need to know to be able to understand the rest of what we're doing. So let's just slip back to the deck. And just before we go into the next set of demos, let's talk about why we want to do this. On the left-hand side of this slide is what we'll see if you're running a virtual machine. You've got your server, you've got your host operating system, and then you've got your hypervisor. On top of that, you have your guest operating system, any binaries and libraries that an application needs, and then the application code itself. If you want a different application running on that virtual machine, then you need to run another guest operating system, another set of binaries, and another set of application code. And this is quite heavyweight, largely because of that guest operating system. It's a complete operating system that we're bringing. On the right-hand side is what happens with containers. So at the bottom, we have our server as before. We have our host operating system. But instead of a hypervisor, we have a container engine. In this case, it's the Docker container engine. And then above that, you have sets of shared binaries and libraries. So you'll note that app A is sharing its binaries and libraries, and app B is sharing it. So we've only got one copy of each. And then above that, you've got your unique application code. And the end result of this is a much smaller package. You saw how quickly those full applications downloaded and installed, much faster than you would get with a virtual machine. And it's because they are so lightweight that happens. And because they're lightweight, you get more density, you get more speed, you get more agility, and many other advantages. So it's all about choice. It's all about flexibility. It's all about scalability. That's why we're working with containers on Azure. This technology is very popular with Linux servers, and of course we've been running Linux containers on Azure for a long time, since version 1.0 of Docker. But we've also started working on, or even providing, it was in the last release, the technical preview 3 release of Windows Server, we're providing Docker support inside of Windows Server itself. And this gives you the choice of running Linux containers or Windows containers, whichever is most appropriate for your use case. One of the big selling points of Docker is portability of workloads. So once you have a container and your application is contained within one of these containers, you can run that anywhere where containers are runnable. So on your own data center, on your Azure account, on your Azure stack, on any other service provider that you wanted to use. And that portability is very, very important. It gives you flexibility, it allows you to scale across different platforms, etc. So what we've looked at so far is we've looked at the Docker Hub. The Docker Hub is where we can get shareable, publicly shareable containers from, but we can also have private containers either in the publicly hosted Docker Hub or in our own version of it. We've looked at the Docker CLI. We've just used it to build, run, and stop containers at this point. But it has a lot of other functionality for managing containers as well. And we've looked at the Docker daemon, which is where these containers actually run. And that's where the standard API comes from that we're conforming to provide that scalability and flexibility that we promised. And this gives us this kind of environment. This is the environment we've been working in so far. We have my developer workstation, and within that we have the Docker host running. Exactly the same thing could be done with my developer workstation and my host being somewhere else. So the Docker CLI works over a TCP connection, and so we can control any machine anywhere with just one change to tell it which machine we want to talk to. So there's no difference with whichever client machine you're using and whichever host you're using. So having understood how we run containers, let's look at how we would build a container. For this, we need to switch back to my demo environment. So here we are again in my demo machine, and we can see we're in a slightly different environment now. If you look on the bottom half, there are two containers running at this point. There is a dev web container, and that contains a PHP application and a web server to serve that application. And there's a dev REST container, which is a Java application that is a Java REST API. It's still a hello world application. I'm going to use a text-based thing, just prevents me having to switch backwards and forwards from one screen to another. But this is a browser, and I'm going to look at the local host, and this is the results of that application. We see we get the heading, hello AzureCon from the PHP application, we get a host identifier, and then we get a message from the Java REST API with a timestamp in it. And if I refresh, you'll see the timestamp updates, but the host stays the same because we only have one host running in this particular application. So we will drop out of that and have a look at how we build that application. Let's have a look at the dev web application. So that is in a folder called web, and we have a file in there called a Docker file. And this is about as simple as a Docker file gets. It defines what the application what the container needs to have in it in order to run. And so the from line at the top is very similar to what we did earlier on when we ran a container. We gave it an image name. And this is an image name, just the same. It's an image name for a PHP application that comes out of Docker Hub. And this part, the 5.6-Apache, is just a version number. And so what that does is it pulls down the PHP container image, and then we copy into that image the contents of our www directory. We copy it into var www. And that's it. We've just built a PHP application. Or at least we've built a PHP container. So what does the application look like? Let's have a look at that. Inside of our web directory, we have our index.php file, and this is our application. So it's very simple. It just says hello, which is this H1 here. We remember it came at the top of the page when we retrieved it. It said hello AzureCon from the PHP web application. And then down here, we have the REST API call. Now, you don't need to worry about how that works. It's just a REST API call written in PHP. But I do want to highlight this here, because it's going to become important in a moment. Note the service URL has the host name REST. I'm going to show you where that comes from shortly. But before I do that, I want to make a little edit. I'm going to remove the word AzureCon from the title here, and I'll write that back to the file. And we'll just have a look now at what localhost will give us. And if you see the title there, the word AzureCon is gone. So this gives us a rapid development iteration. We're able to edit our application and see the changes immediately without rebuilding the container. So what happened here, because when I was showing you the Docker file, I said it copies into the container the contents of that directory. Yet when I changed it on my local machine, it changed in the container as well. So how did we do that? To see how that happens, we need to look at a script that I use to start that particular container. We'll scroll down. The beginning parts is just some configuration that we don't need to worry about in this context. The interesting parts start here. Docker build, that's a new command to the same command line we had before. Give a tag to this container called web latest and use the Docker file in our current directory. And that will build the container, and it will copy in the current content into that container. So if we were to run that container, we wouldn't be able to edit it. These containers are intended to be immutable. So how did we get to the point of being able to edit it? Docker stop dev web stops any existing containers that are running. We remove it as well to make sure that there's no containers left behind to cause us problems. And then we run it. And this is the interesting line. We run it just the same as we did before. We use the detach mode, but then we have this -v switch, which is a volume switch. It mounts a volume into the container. PWD is Linux speak for my current directory. And then it's the www directory, the same one we were copying in before, and we're mapping it into the same place. So it dynamically maps the local file system into the container. We then do the same port mapping that we did earlier on. We're actually using a environment variable here, but it's the same result. And then we have this new command, link. What we're doing here is we're linking a container called dev rest into this container, and we're giving it a host name of rest. So you remember when I pointed out the URL earlier on? This is where it comes from. This is how we connect containers together in our application. We give it a name, dev web, that's so we know how to delete it and remove it later on, and we tell it to use the latest version of the web image that we just built. So that's the dev environment. To put it in a production environment, you just don't put the -v part in. So you don't mount the local file system, you use the file system that's in the container itself. Okay, so let's switch back to our slides, and let's see what we recap what we've just looked at. We've looked at building Docker containers. We've looked at how we link containers together in an application and how we mount volumes in order to speed up the development process. We've looked at some management scripts that will help us build and deploy that application. But I want to make the point here that scripts for that kind of thing are very brittle, and I want to replace those. That's what we're going to do next. And then we looked at testing. We didn't actually do any formal testing here. We just did some manual validation by opening up a browser and looking at it. But if you do download the source code for this, you'll see that there is actually some testing, which is also containerized and will be run for you at the same time. I just, in the interest of speed, didn't use those here. So I said that those scripts are brittle and we want to get rid of them. We need to be able to use configuration as code to make sure that everything is repeatable and manageable. And we also want to solve a problem that we have in the current application, which is it's not scalable. We only have one web server and it won't scale. Now, as we switch to configuration as code, that scalability becomes much easier. So we're going to do the two things at the same time. So let's switch back to the dev machine. And we have a new development environment here, our new setup, and you can see there's no containers running at this particular point in time. So let's get those containers running. Let's start our application. We're going to introduce a new command here, docker compose. We're going to say up, and we're going to run in detached mode to bring it back to my command prompt. And what this is doing is it's starting up the 3 containers. I said 3 containers, that's right. It's the same 2 containers we had before, the web container and the REST container, and they're exactly the same with no changes. The 3rd container is a load balancer, and that's the scaling that we're going to introduce, and we'll talk about that again in a moment. But if I do a Linux localhost, we can see that this is exactly the same. It's not using the dynamic version, it's using the fixed version, so we still have the AzureCon, because when we built it, it had the word AzureCon in the title. So it's a production version that we're using here. And then we can go back to our command prompt and have a look at how we did that. Let's have a look at the Docker Compose file. So this is our configuration as code. We're going to skip over the top section for a moment. That's the load balancer. We'll come back to that in a moment. But here is the definition for the web container. And it's exactly the same as what we did in that script, but simpler. We're saying if you need to build this container, then build the contents that you'll find in web. That's where you'll find the Docker file to tell you how to build this container. Expose port 80 and link it to the REST container. And then we have the same definition for REST. We didn't look at the script before, but it's very similar. And the definition is very similar as well. We're saying build the container that's defined in the directory Java and expose port 8080. Now, there's one difference in the web container to what we did in the script. We're not exposing port 80 on the VM here. We're only exposing port 80 on the container. And that's because we're doing the load balancing. So let's have a look at that. The load balancer is the different definition here. And here we're not building our own container locally. We're pulling one down from the Docker Hub. So we're using an image, and it's called EEA-CMS/HA proxy. HA proxy is an open source proxy that works very well with Docker, and I'm using it here to do some load balancing. We're exposing port 80 on the virtual machine. That's before the colon, and we're mapping it to port 80 on this particular container. We're also exposing 1936, but we're not going to look at that. That's an analytics port, but we're not going to look at that today. And we want this proxy to be linked to any containers called web. So this replaces all of the scripting that I had before. You saw about 20 or 30 lines of scripting to just do the web container, and there was the same for the REST container. There would have been the same for the load balancer had I been doing that in scripts. And we've replaced it with just a few lines of configuration here. That's how it comes up. And I promised we were going to scale this application as well. And I promised that Docker Compose would help us do that. So if we type Docker Compose and we say scale web, let's say we want to have 5 web services, web containers running, because our application is so wonderful, we're getting lots of hits. And you'll see in the bottom there that there are now 5 web containers being run. And if I do the links command again, if you watch the host name here, we're in a round-robin proxy. So each time I refresh, we will see the host name changing, as well as the timestamp from the Java API. And it'll just cycle round in a round-robin fashion. So we now have a scalable application simply by putting a few lines of configuration in our compose file. So how about scaling down? It's exactly the same. We say Docker Compose scale, and let's say we only want 2 now. So we've killed 3 of the 5 web containers. We go back to links, and if I refresh, we just bounce between the 2 hosts. So now we can scale up and scale down extremely easily. All this is happening transparently. There's no scripting happening here, and we can manage this from any machine and have it running in Azure, on-premise, on my local machine, anywhere I want it. So let's just recap that before moving on to the next section. We've looked at how we might build a containerized application. We've looked at the Docker files for individual containers, and then Docker Compose to put the whole application together. We've looked at Docker Compose Up, which will rebuild our containers as necessary, and it'll run any containers that we need. And we've looked at Docker Compose Scale, which allows us to scale up and scale down on any containers that are capable of being scaled up and down. So we're doing really well here. We're moving forward nicely, but we've got a limitation. Now we're able to scale our application up and down, but only on a single host. We're only using a single physical machine here. And there's obvious limitations to that. We probably want to scale across multiple machines, across different geographic regions, etc. So let's have a look at what we would do there. This is the setup we've had so far. We have a developer workstation which communicates with a single Docker host, either locally on the workstation in a development environment or out in the cloud in a production environment. Or it could be on-premise or wherever you want it. To do a truly scalable app, though, this is what we need. We need containers running on multiple hosts. But now we've got to figure out where are the containers, how are we going to manage them, where are we going to run them? And our developer workstation has become much more complex now, or our use of the command line to manage these containers become much more complex. We need to track a lot of information. Fortunately, Docker has a solution to this. Docker Swarm is a product, it's a scheduler, which will allow us to communicate with Docker Swarm, which in turn communicates with multiple Docker hosts. And so from our point of view, we think we're only talking to a single host, but in fact, we're talking to multiple hosts. Docker Swarm does all of the management of that for us. So Swarm is a new project, relatively new project, and it works very well. But it has some limitations. It'll only work with containers. It won't work with other types of microservices, for example. Its orchestration and a layer is quite primitive at this point. And many people want to use a project such as Apache Mesos. Mesos is a very mature orchestrator. It's used an awful lot in many production environments. And what Mesos does is similar to Swarm in that it makes multiple machines look like a single machine. And you can use Swarm and Mesos together so that Mesos does the orchestration and Swarm does the management of the containers for you. So that's what we're looking at doing, and we'll have a look at how that would work moving forwards. So what are we doing for managing containers as microservices and using orchestration tools like Mesos? Our goal is to simplify the whole process. But simplifying the process is never as simple as it should be. Some people want Swarm and Mesos. Some people want Marathon and Mesos. Some people want Kronos and Mesos. Some people want Kubernetes. Some people want other things. And as we move forward in this very rapidly innovating environment, we're going to find customers who want lots and lots of different combinations of tools. And that increases the complexity. And I'm not even started talking about networking and storage and many other things that you need in a real application. So a diagram like this becomes hugely complex once we start adding all of those elements in. So simplifying this is not as easy as it looks. It turns out that we've been working towards creating a much simpler way of building container services on Azure for some time. We have Azure for the cloud. We have Azure Stack for on-premise. We can run VMs and we can scale VMs up and down, as you'll be hearing about in other sessions in this conference. We've been working on both Windows Server and Linux support in both of those environments and supporting the containers running on those. As a result of that work and our standardization on the community-defined APIs around containers, you can use any container tooling to manage containers on this infrastructure. Using ARM templates, you can build any environment that you want. You can use Mesos, you can use Kubernetes, you can use any standard API compliant technology to build services for yourself on Azure. But it's complex to do so, and I'll show you just how complex in a few moments. What we're now focusing on is this line here. We're focusing on making it easier to start up specific best practice container services, one example of which would be Swarm plus Mesos. What we're doing is taking a very layered approach. So our first version, which we're talking about today, is going to provide these top 4 layers. So configuration as code, which will be ARM to define the infrastructure, the Docker file to define containers, and Docker Compose to define applications. Cluster management, so that will be VM scale sets. Container orchestration, so Swarm, Kronos, Marathon, and Mesos. Monitoring, we have a plugin for OMS that will help monitor container workloads. And then moving forwards, we'll start looking at things like storage, container networking, security, the DevOps pipeline, identity, and tooling and integration. So focusing just on those top 4, this is the kind of thing that we're looking at building, and you can build today. I'll show you a template that will enable this to be built. On the right-hand side, we have an agent availability set. This is where we run our microservices and our containers. On the left and in the center here, we have our master availability set. This is where all of our master controlling software is. It's where we have Mesos, it's where we have Swarm and Marathon and so on. We open up a set of public IPs to enable us to communicate with those applications and run workloads via those masters. And then on the left-hand side, we have an optional jump box, which enables you to get inside of the subnet and debug anything that's happening within your environment if you need to do so. Now, to build that is complex. Let's have a look at just how complex it is. We've got an Azure Quick Start template. Now, an Azure Quick Start template is an ARM template. It's a configuration of code for Azure infrastructure. A Quick Start template is a GitHub repository that has a lot of templates on it that provide examples of how to do things. And you'll find one on there which provides exactly that configuration that I was just showing you. And I just want to highlight how complex this is. If I go into the Azure deploy JSON file, don't worry if you don't understand what ARM templates are. Definitely complex to you in that case. But even if you know what they are, just look at the scale of this template. It's 460 lines in just this one file. If I go back to the main listing, you'll see that there's not just that one file, there's also another one which is used to configure the agent, which is this one. And this is another 248 lines. And then we have one to configure the masters. And that's another 351 lines, and so on. There's the jump box, and there's all sorts of other configuration items. So we're already at well over 1,000 lines of configuration code to build a service like that, which is complex but useful. If I switch to the jump box for one of those running services, this is what you would see. This is the Mesos interface, and we can see down the bottom here, we have 6 CPUs and just over 17 gig of memory available. At the moment, all of those 6 CPUs are being used and 5 gig of the memory is being used. Up on the top right here, we're seeing the jobs that are being run. There's 3 jobs, one being run by Kronos. That runs a particular task every day. In this case, the task it's running is a folding at home task, which is a great project you should look up. It simulates folding proteins to help people build drugs and therapies to cure cancer and Alzheimer's and things like that. Fantastic use of time. When I'm doing a demo like this, for example, we're also helping to cure some pretty important diseases. And then the other 2 are marathon tasks that are running the same task. We can flick through to, for example, the Kronos configuration for that task. And you can see over here is the command, sorry, jumping around a bit, there we go, is the command that runs that task, and it's docker run rgardler/FAH for folding at home. So it's just running a Docker container, and the marathon jobs are also running the same Docker container. So we get a full system with orchestrator and various different schedulers installed on it in a couple of thousand lines of ARM code. But we can do better than that. We want to do better than that. Our goal is to provide something that would simplify that whole process for commonly found configurations of tooling like that. So let's have a look at what that might look like. And this is our current thinking. I would love feedback on where we're going on this to make sure we're heading in the right direction. But this is what it would look like. We're going to make the containers a first-class resource within ARM. So instead of having thousands of lines of code, you will have a simple structure such as this that says, I want a compute container service, and I want it to be called my container service, and I want it to be located in this location. You'll have the option of configuring it, but there'll be sensible defaults. So you could put configuration in like this to say how many agents I want, how many masters I want, what jump box type I want. You will need to provide a little bit of configuration. These are the required configuration. Username and password for your jump box, and DNS name for the jump box and for the container service itself. And then that's it. So once you've put this into a full ARM template, it'll be somewhere between 100 and 200 lines, depending how much configuration you do. So it's a great improvement from a couple of thousand lines down to maybe a couple of hundred lines for a highly configured environment. That's our goal. That's where we're heading to. We're building the resource provider right now to do this, and we expect to be able to make that available fairly soon. So to sum up, we're going to be making containers a first-class citizen in ARM. That's a new resource provider. We're taking a very layered approach in what we provide within this container service. And that approach enables us to be very agile. It enables us to move with the innovation that's happening in this space. It's a very fast-moving space at this point. And customers are not yet certain about what they want. They want the agility to be able to switch to new versions or new approaches to implementing these kinds of services. And that's what we're focusing on doing here. We are conforming to all of the community-defined APIs. That's part of the agility goal that we have above. We're active within these communities to make sure that we can build what the customers need with their software. What this ultimately means is your hosts become cattle. You don't have to worry about them anymore. You will handle the operating system uploads, will handle the upgrades, etc. You just say you need these container services, and that's what you'll get. In terms of your actual application, well, it's up to you. You can use it, you can have pets, you can have cattle, you can have any combination of the two, because how you build your application on top of this is up to you. You can use whatever practices work well for you. Okay, so that's what containers are as a first-class resource in ARM. And that's the end of my session. So I hope you enjoyed it. I hope you found it useful. Please do go and download the code from GitHub for the demos that I did. Try them out. Try the Azure Quick Start template. See what happens there. Do raise issues. If you come across issues, we'll do our best to help. And thank you very much for listening.